Hello everybody. So we're tackling part B of that previous problem, and now this says, it has been shown that a particular gas may be described by equations of state of the form U equals 3PV, P equals P, which is only a function of T, where U is the internal energy and P is the pressure, which only depends on the temperature. Using this relation, show that the equations, show that these two equations imply that for this gas, pressure can be expressed by the formula this. So immediately what I'm going to first do is try and write this out in terms of these. So du dv at constant t, I have to differentiate this with respect to v at constant t. And because there's no v here, there's no t here, I don't even have to worry about that. So del u del v at constant t is simply equal to 3p. Del p del t at constant v is simply equal to, it's because it's only a function of t and there's no v that we're worried about. It's just basically p prime of this, okay? Cool, so now let me rewrite this whole thing like this. So that says that 3p equals t times p prime of t, and I'm going to drop this of t because this can just be written as p prime, because the more things I have in here, it's just going to make it more confusing for me. So I can really just write this as dp dt. dp dt, yes. dp dt, right? Plus, or minus p, right? So that's this, okay? Now what we're going to go ahead and do, I'm going to try and separate my variables, and I can already see that I can add a p to this side, and 3p plus p gives me 4p. So 4p is equal to t dp dt. And I can sort of see this 4 coming in here. So I sort of like that. That maybe lets me know I'm on the right track. However, this 4 is attached to a t rather than the p. So I want this 4 to be, so I'm going to try and separate these, but I want this 4 to be on the side of the t's. Okay? Now, how would I go about doing that? 4 dt is equal to 4 dt over t is equal to dp over p. Yes. Cool. Now let me take the integral of both sides, and because this is a 4, I can sort of pull this out of the integral, right, because it's a constant, and I'm going to integrate from an initial t to a final t and an initial p to a final p, okay? Now once I do that, that's going to give me 4 times ln of t minus ln of t naught, okay? Now, this side is going to give me ln of p minus ln of p naught. Okay, that looks good. Now, this rules of logarithms say that this is equal to this, isn't it? T over t naught. And likewise, ln of this would be this, right? Cool. What can I do now here? Okay, so now I can bring this like this. I can say this, right? ln of t over t naught to the 4th. Isn't this just equal to this? Rules of logarithms, right? Is equal to this. Okay. Okay. Now I'm gonna raise both of these to the e power, or I'm gonna take e raised to the both of these power, right? So once I do that, this cancels out, e cancels out with ln, e cancels out with ln, so I'm left with this. I'll bring this over here. T over t naught. And I'll okay, let me just not skip steps. So this is this, right? And can't this just be given by like t to the 4th over t naught to the fourth is equal to p over p naught, right? Now, I'm trying to solve for this p, right? Yes, because like these p's are just functions of t's, right? They didn't change as we were dealing with them, right? So I can go ahead and say p naught t to the fourth. I'll write p naught of t times t to the fourth all over t naught to the fourth is equal to p of t, right? Cool. Now, I'll bring this over here. Isn't this just this? Isn't this just a constant? So if I took this whole thing to be a c, right, I could say that p of t is equal to c times t to the fourth. And that's really what they just asked us to prove, okay? So just takes a little bit of manipulation. Now what I originally could have done here also was I could have ended up separating my p's down here, so I'd have had like, I could have ended up having this. I could have done that, right? But why didn't I do that? Because I could see that this t to the fourth was attached, this 4 was attached to a t. This would have attached my 4 to a p. So I didn't want that. So that's why I ended up doing that instead and attaching my 4 to my t, or leaving it attached, or attaching my 4 to my t rather. So if anything was unclear, please don't hesitate to ask in the comments. I'll do my best to answer them. And let's keep learning thermal. Thank you.